Welcome to another 5-minute tutorial for the Level 3 Technical Certificate in Papermaking. Today we're going to talk about the Deculator. The Deculator is a device for removing air. There are chemical methods of removing air such as antifoamers and defoamers, and there's a physical method which is the Deculator, so named after Deculator, the inventor of the device. We use the Deculator to remove air because air I consider to be the unseen enemy. Now with air, there are at least six different problems that you can get, and I've broken them down into 3 process problems and 3 paper making problems. So the process problems are bacterial growth is number 1. Bacteria need 3 things in order to not just survive but to multiply. They need a nice warm wet environment, which is the paper making system. They need good food to eat, which is cellulose and all the cellulosics that are soluble and insoluble in the paper making system. And they need oxygen, they need air to breathe, just like we need air to breathe. Bacteria need air to breathe. So the more you can keep air out of the system, the more you will restrict the growth of bacteria and the less bactericides you'll need to use. The other thing is cavitation in pumps. If you've got air in your stock, as it goes through a pump, it will physically get knocked out and it can stay in the pump. And I'm sure we've all heard when a pump's cavitating, this bang, bang, bang noise. So it's damaging the pump. It's causing you to use a lot more electricity to pump the volume that you want. And it's a health and safety hazard because it's really too loud. So it can help to reduce cavitation by keeping air out. And the other thing is corrosion. Corrosion is caused by oxygen. There's a lot of oxygen in air. The more you encourage oxygen to go around, the more likely you are to corrode things. So other than the 3 process problems, there are also 3 paper making problems. And the 3 paper making problems, pore formation. Some of the air is about the same size as the fibre. And what it does is it drags all the fibres together, and so it forms flocks. So air in your stock can give you a very poor formation, very flocky paper. If you've got a flocky paper, that means you've got more fibres in one place than there should be, therefore you'll have less fibres somewhere else than there should be. And if you've got less fibres where there should be, then you're going to get poor strength problems. And the final thing, of course, is if you've got air in your stock, if at some point during the formation of the sheet a bubble bursts, then where there was a bubble there was no water, where there was no water there was no fibre, so when the bubble bursts you end up with a pinhole in the sheet. So all these reasons for getting rid of air in stock. And there are 3 different types of air, nothing's ever as simple as it looks. The 3 types of air is, first of all, you've got free air. Free air, that really means relatively large bubbles of air, and those are the easiest ones to get rid of. If you're in a big storage vessel, then just the slow rotation of the paddle in the storage vessel will be enough to dislodge those bubbles of air and bring them to the top, and they'll pop and disappear, so that's not a problem. The most dangerous sort of air is this one. It's called residual air. And residual air is much, much smaller bubbles. These bubbles are round about the same size as a fibre. And these are the ones that will attach themselves to fibres, drag all the fibres together and give you that flocculation effect. And the 3rd type of air is what we call dissolved air. So this is the sort of air that you get in fizzy drinks. And as you know, when you release the top on a fizzy drink, all the air that you cannot see all comes out of solution, it aggregates, and it then becomes bubbles that you can see. Similarly in paper making, dissolved air, the bits will get together and they will become residual air, which is the most damaging of all the different types of air. How do we get rid of it? We get rid of a deculator. What does a deculator look like? It's something that we keep fairly high up in the process, and it's basically like a big tank that we apply vacuum to. And what we do is we apply so much vacuum that when we push the stock in there, it will boil at whatever temperature it's at. One of the questions I often ask my students is what temperature does water boil at? And the standard answer is normally 100 degrees C, and then I laugh at them and tell them they're wrong because it all depends on what the pressure is around it. If you go deep down into a cave, it'll boil at more than 100 degrees C. If you go high up in a mountain, it'll boil at a lot less than 100 degrees C. So boiling of water depends on the atmospheric pressure that you're at the time. So what they do is, most stock in paper machines is somewhere between maybe 40 and 60, 65, maybe even 70 degrees C. And they bring the stock in this case, the deculator is after the final screen, just before the floor box. So we bring the stock in, it goes through a final screening, we shoot it up into the deculator. Very high vacuum in the deculator, everything boils, the water gets sucked, the air gets sucked out, the water falls down, overflows, and then through the fan pump and into the head box or into the floor box. If you don't have it after the final screen, it's more common to have it just before just after the cleaners and before that final screen. And this really shows you the mechanism of what's going on. So we bring some stock in, put it through a cleaner, rejects go at the bottom, accepts go at the top, and we really fire them very hard so that they hit the top of the deculator, and that shatters that jet of water and shatters it into thousands of tiny little droplets that may only be a millimetre or two across. That way, when we apply this high vacuum, the air that's going to get sucked out of that water droplet only has to travel maybe half a millimetre. So we suck all the air out, we make the water boil, the air gets carried away by vacuum, the water drops to the bottom and becomes overflow, and then off it goes onto the machine. Just a little graph to show you about water boiling temperature and pressure. This is the pressure in atmospheres, this is the temperature of water boiling. As you can see, at around about 4 atmosphere pressure, water will boil at nearly 150 degrees C. As the pressure drops, it gets to 1 atmosphere where it boils at 100 degrees C, and if you reduce the pressure even more, then it will continue to reduce the boiling point of water. If you have the time, there's an interesting little video here done by Nottingham University, one of their series of periodic table of videos. And what they've done is they've climbed up to the base camp of Mount Everest, and every time they stop, they've taken some water, boiled it, and measured the temperature of water. It takes about 10 minutes to watch that video, so if you have the time, it's interesting to watch it. It's on YouTube. Type in water boiling Everest, or type in that link that you'll see there, and it's just an amusing little 10 minutes. So a summary of what we've talked about in this video: air in stock causes 3 process problems and 3 paper making problems. The process problems: BCC, bacteria, cavitation, corrosion. 3 paper making problems: formation, strength, pinons. Of the 3 different types of air, residual air is the most dangerous. Dissolved air can become residual air, and the lower the pressure, the lower the boiling point. That's the end of this little tutorial. Hope you've enjoyed it. Please follow us on any of these social media